Hello, and welcome back to Flexsim Geek. Today, we're going to explore a case study where an AGV, automated guided vehicle, is utilized to collect and distribute packages along a queue. As you can see here. So let's get started. Let's start building the model by opening Flexsim and clicking on New Model. In the Model Units window, I'll select time in seconds and leave the rest of the values as they are. I'll start building the model by placing the AGV path in the model space. I'll also add 2 additional paths like this, for placing the AGV when it's in the not required state. Next, I'll add the necessary control points along the AGV path to ensure proper operation. Now, I'll add queues at the respective positions of the control points. I'll place a source connected to Q1, and link it via an A connection to the control point, like this. Then, I'll connect the second control point to Q2, and link the output of Q2 to a processor. From the processor, I'll create 2 output connections going to Q3 and Q4, and connect those queues to their respective control points. I'll also add a processor after Q5, and connect its output to a sink, just like this. Finally, I'll add the AGV to the model, along with a control point for the AGV, and connect it accordingly. The 3D model is now complete. Let's move on to adding the process flow to the model. I'll start by adding an event-triggered source. I'll place it and set the reference to Q1, with the event set to onPush. Next, I'll add a push-to-list activity, placing it just below the source. Then, I'll attach a sink to the process flow, like this. Now, I'll place a list from the Features panel and link the push-to-list activity to this specific list. I'll repeat a similar setup for queues 3 and 4, adding event-triggered sources, linking them to their respective queues, and configuring them with push-to-list activities that reference the same list. Now, for each event-triggered source, I need to assign labels to the entering item. I'll assign a label named item, and specify the operation to be performed. I'll repeat this process for all the event-triggered sources. Now, let's add the remaining logic to the process flow. I'll begin by adding a scheduled source to the model, with the quantity set to 1. Next, I'll add an acquire resource activity to the process flow. This will be used to reference the AGV. Then, I'll add a resource to the process flow and assign the AGV as its reference, just like this. I'll connect these elements accordingly. Now, I'll add a decide activity to the process flow and rename it appropriately. I'll set the decision type to condition decide. For the condition, I'll refer to the queue's subnode.length and set the condition to less than or equal to 5. If the condition is true, I'll add a pull from list activity. I'll refer this pull from list to the list Q1. In the pull from list activity, I'll set both the request and required token values to 5. I'll also assign a label to the pulled items using token.pulled_first, as 2 more pull requests are required to complete the model. I'll check the all or nothing checkbox and enable the use max timer option. Inside the use max timer settings of the release token activity, I'll set the release destination to port 2. After the tokens are pulled from the list, I'll add a travel activity to the process flow. This will direct the AGV to travel to Q1. Once the AGV reaches Q1, it will load the items. After loading, the AGV will then travel to Q2 to place the items. I'll add 2 travel and 2 move object activities to complete this part of the process flow. In the travel activities, I'll set the task executor to token AGV, since we've assigned the acquired AGV resource to this label. In the first travel activity, I'll set the destination to Q1. Then, in the first move object activity, I'll set the items to token.pulled first. In the destination, I'll set it to token.agv. In the second travel activity, I'll set the destination to Q2. Finally, in the second move object activity, I'll set the destination to Q2, so the AGV unloads the items at the correct location. After this process, I'll add another decide activity. I'll rename it appropriately. In the send token section, I'll set it to conditional decide. In the condition area, I'll reference Q5, and add a condition such as subnodes.length less than equals 5. I'll connect it just like this. After the decision condition, I'll place a pull from list activity. I'll rename it appropriately as well. This pull from list activity will be linked to Q3, just like this. Inside this pull from list activity, I'll assign the label of the pulled item to token.pulledSecond. Make sure to check the checkbox all or nothing, and enable the use max timer option, just like we did earlier with the first pull from list activity. Now, I'll set both the requested and required token numbers to 5. Just like before, we'll now add a travel activity connected to this pull from list. I'll add the travel activity, set the task executor to token.agv, and the destination to Q3. Next, I'll add a move object activity. In the objects section, I'll change it to token.pulledSecond, and set the destination to token.agv. Now, I'll add a second travel activity, and this time set the task executor to AGV, and the destination to Q5. Finally, I'll add another move object activity. Just like we did earlier, we need to move the items from the AGV to Q5. Just like we did before, set the items to token.pulledSecond, and set the destination to Q5. Now, we've completed the logic to transfer items from Q3 to Q5. Next, we need to do the same for Q4. To achieve this, we'll follow the exact same process as before. Here, the pull from list activity is referring to the list from Q4. You can follow along with me as we build this out. After completing the third pull from list process, you just need to update the relevant items and set the correct destination in both the travel and move object activities. You can follow along with me. Now, we need to loop this process. To do that, after completing the third section, I'll use a connector to link it back to the first decide activity, just like this. I'll use a split connector here. I'll also drop a connection from the second pull from list to the third pull from list, which means, if the AGV doesn't find items in Q3, it will go check Q4, completing the loop. Next, I'll add a breathe activity and connect it from the second decide and third pull from list activity. Now, I'll add one more decide activity and attach it to the breathe. This decide activity works similarly to what we discussed earlier. Inside this decide activity, I'll write a custom code to check the number of items in Q1, Q3, and Q4. You can follow along as I write the code. I'll add an if statement that checks whether any of these three queues contain more than 5 items. We'll use an OR logic for this. If any of the queues, Q1, Q3, or Q4, has more than 5 items, we'll return 1. Otherwise, we'll return 2. Now, I'll connect port 1 of this decide activity back to the first decide activity using a split connector. Port 1 represents the condition being true, that is, when at least one of the queues has more than 5 items. After that, I'll add an acquire resource activity and connect it from port 2 of the decide activity, which corresponds to the false condition, meaning all the queues have 5 or fewer items. Now, I'll add one more resource, in addition to the AGV, and rename it locations. What we need to do here is reference these locations, so that if the AGV is not required, it can be parked in one of them. To do this, I'll create a group of locations by going to the toolbar, clicking on Group, and then selecting the relevant locations. In the resource activity, I'll reference the location group we created earlier. Next, I'll provide a reference to this group in the acquire resource activity. Just like this. In the activity section, I'll rename the acquired resource as token.locations. Now, I'll add a travel activity so that when the decide condition is false, the AGV moves to its parking location. In this travel activity, I'll set the task executor to AGV, and the destination to token.location. Next, I'll add a wait for event activity to listen for updates in the queues, specifically to check whether any new items are added. In the activity section of the wait for event, I'll refer all 3 listed queues, Q1, Q3, and Q4, and set the event to on push. As you can see here, it's configured like this. After that, I'll add a breathe activity and connect it to the wait for event. Now, I'll place another decide activity. This one will perform the same condition check as the one we added earlier. So let's add the custom code again. I'll simply copy the logic from the previous decide activity, the same check for whether any of the 3 queues has more than 5 items. Alright. Now I'll add a release resource activity and connect it from the port 1 from the decide. Inside the release activity, I'll change the resource label to token.location. From the release resource activity, I'll connect back to the first decide activity, closing the loop for when items are ready to be processed again. Now, for the second port of this decide activity, which is the false condition, I'll connect it back to the wait for event activity. This creates a loop that continues to monitor the queues until at least one of them contains 5 or more items. Alright, that's it for the entire process flow. Now, we can go ahead and run the model and test if everything works as expected. As you can see, the AGV is performing its task as intended. It will only collect items from the queue when the number of items is greater than or equal to 5. If not, it will automatically move to the parking station. That's it for today's video. Thanks for watching.